next video. In today's video I will show you how to render a 3D model in native Android application, given that the 3D model is on network, like it might be on your server or it might be on AWS S3, it might be on Firebase storage, any place apart, like it might so I have already made a video on how to load a 3D model given that it is present inside your app itself, but here we will download it from the network. Now firstly I will show you the output. So here is the output. Like I have this Fox GLB model running. It has a running animation and it is downloaded from the network. First thing first is from where you will get this gltf model. Before that I want to clarify that I already have made a video on this, but previously there was a lot of unnecessary code in my tutorial. I have found a simpler method to display a glb model or gltf model in native Android application. That's why I'm making one more tutorial for this. Second is you will require a glb model. What is glb? It is gltf binary, which you see over here. Like it has all the gltf files in one binary itself. So if you want to download, you can go over to this GitHub repo, and it has various glb models. So suppose if I picks avocado, then you will have to select this gltf binary. Next also you will have to, so we will be using this Filament library which will help us to render 3D models. And also if you check my 3D model, it has a background to it. So to download the background, you will have to download these files and store it inside your projects. Now these files are extremely small, so you don't need to download it from the network. And if you don't download this file, like your 3D model, your environment will be extremely black, so you would be confused like whether my 3D model has really been rendered or not. Next thing is it could be very well possible that your 3D model has animations. Now to check animations, you can just go to this website and drag and drop your glb model over here. So I have dragged and drop, and here you can see that this Fox has 3 animations. So survey, walk and run. So in native Android we will pass it as 0, 1 and 2. So 0 would be for survey, 1 would be for walk, and 2 would be for run. So here I am playing the run animation, and I will show you exactly where you need to pass this animation. Okay, so as usual, just create a native Android application. Next you will have to go to Android manifest and add this internet permission. Next you will have to go to build.gradle.kts, and you will have to add this retrofit dependency for downloading the model from network, and you will have to add this Filament dependency for rendering the 3D model. And this is our lifecycle dependency which will be required for working with coroutines. Next I have created this URL parts data class, because if you remember, retrofit requires a base URL, then it requires the rest of the URL. That's why to split our URL into 2 parts, I am using this helper data class. So URL parts, which consist of base URL and rest of URL. Next I have defined an interface, and this is the way of doing things in retrofit. So this is the code for downloading the file from a network. I mean, not the exact code, but just the interface. Next, inside main activity, if you see my layout file, activity underscore main, I have just taken a surface view and it is occupying the entire width and height. Next this code is for loading your Filament library as soon as your app is opened. Next I have created a surface view. Now these things I still don't know what is a choreographer, UI helper, model viewer, but just like these are like boilerplate code which we require for making for using Filament. Similarly over here as well. And this path and file is because we will be storing our model once it is downloaded inside our internal storage, so that if for the next time if you try to open your app, it will be immediately showing your 3D model instead of downloading from the network. Next, here you have to pass your URL. Now this is not a correct URL, so pass your own URL. So it could be anything, AWS S3, your server URL, wherever your GLB file is hosted. Next, the file name is very important. So suppose tomorrow you change this URL, but if you kept the file name as same, it will keep showing the old GLB model. So it's important because when I cache the file, it is stored with the same file name. That's why it's important you update the file name as well if you update your URL. Next, as I was telling you, the animation index. So 2 is for run, right? Here I am passing the animation index. So here you can pass 0 or 1 as well. Suppose you pass 3, 4, 5, something like that, which is not part of our GLB, then I have added a check for that. In that case, no animation would be placed for your GLB model. Next, here we are initializing our surface view. Then again, this is boilerplate code which I have just copied from the documentation. Here is the touch listener for our surface view. First, so we are downloading the gltf model, then creating an indirect light and configure viewer. Also, one more thing which I forgot was you have to create this assets folder and you have to drag and drop those files which you have downloaded from the Filament repo over here. Next, this is for creating our path. So this is where our gltf model will be saved, and here I am splitting our URL, so I would get the base URL as well as the rest of the URL. So I won't explain this much. Okay. Next, here we are downloading the model. So first I am checking if the file exists or not. If yes, then I am just passing the internal storage cached model. Otherwise, here we are creating our HTTP client for retrofit as well as instantiating our retrofit class, then downloading our file, and if successful, then we are saving it to our internal storage and returning. Otherwise, we are just returning null in case of failure. And this is how we are saving our file. So we will get an input stream, and from this we are creating file output stream. Again, like I have just copy pasted it from the docs. So this is how you save file. Next, here we are downloading again our gltf. So this is the code for it. Here we are creating our file. Okay, and here is our byte array, and this is for the buffered input stream, and this is for creating the default renderables. And in case if something goes wrong, I'm just displaying a toast message. And this is for default renderables. So like here we are just loading our gltf model which we have downloaded. And next we are doing update route and transform. I am not really sure what this is used for. And here we are configuring our viewer. So this is mostly about the render quality. I think it is mostly about how your 3D model would look like. Again, this is boilerplate code which I have just copied from documentation. And here we have to create indirect light. So here we will be using this assets which we files which you have copied in assets. So make sure, in case you have changed the name, make sure you change it over here as well, and over here and over here as well. Next, here we are reading the compressed assets, so helper class which I have created, and I have also created a frame callback, and I have using the start time. And if you check over here, we are passing the animation index. So I have added a check in case you are passing any wrong animation index, then this won't get applied. Okay, and this is like boilerplate code for playing the animation. And on resume, we will play the animation. On pause, we will remove the animation, and on destroy, again we will remove the animation. In case if you have a button on which you want to update the animation index, you can just add a click listener to the button, update your animation index, and also don't forget to call this. So this is important. Once you call this, then only your animation new animation will start playing. So yeah, that's it. Thank you for watching. Bye.